How did lockout-tagout failures lead to fatal accidents? Imagine working on a piece of heavy machinery or electrical equipment, thinking everything is safe because you've followed the usual steps. Suddenly, the machine starts up unexpectedly. This kind of accident can be deadly. When lockout-tagout failures happen, workers face serious risks. These failures often happen because not all energy sources are fully isolated. Machines can have electrical, mechanical, hydraulic, or thermal energy stored in them. If even one source remains active, it can cause injury or death. One common problem is incomplete energy isolation. For example, turning off a main switch might not cut power to secondary circuits or stored energy in capacitors. If these aren't properly disconnected or discharged, the equipment can energize unexpectedly. Workers might think they are safe after switching off a device, but residual energy can still cause shocks or movement. That's why verifying zero energy state is so important. Testing for voltage or pressure ensures no energy remains. Skipping these steps increases the chance of a fatal accident. Human factors also play a big role. Workers sometimes become complacent, especially if they've done similar tasks before. They might remove locks early or ignore safety tags, thinking nothing will happen. This dangerous shortcut can lead to sudden re-energization of equipment, causing electrocution or crushing injuries. Proper training is essential to prevent this. When workers understand the risks of residual energy and follow strict procedures, accidents are less likely. Procedural gaps can also cause failures. If lockout procedures are not detailed or specific to the equipment, workers might miss isolating certain energy sources. For example, a machine with multiple power feeds or stored energy in springs needs a comprehensive plan. Without clear instructions, assumptions are made, and hazards are overlooked. Each worker should have their own lock and tag. Sharing locks or using master keys can lead to re-energization without proper control. Inadequate training is another factor. Workers need to know how to identify all energy sources and verify that equipment is safe to work on. If they are unsure or unaware of the hazards, they might skip critical steps. Regular training sessions and refreshers help reinforce safety habits. Equipment and lockout devices matter too. Using the wrong lock or sharing one among workers can cause confusion. Each person should have their own lock to prevent accidental re-energization. Properly maintained and tested locking devices ensure that equipment stays off until everyone is ready. To prevent these failures, companies should develop detailed lockout procedures tailored to each piece of equipment. Training must emphasize verifying zero energy and following steps carefully. Using individual locks and tags keeps control in the hands of each worker. Safety culture is key. Everyone should see lockout-tagout as a vital safety measure, not just a bureaucratic task. In the end, lockout-tagout failures lead to fatal accidents when energy isn't fully controlled. This can happen because of incomplete isolation, human mistakes, poor procedures, or faulty equipment. Following strict electrical safety standards and understanding the principles of energy control are the best ways to protect workers. Proper training, thorough procedures, and accountability make all the difference in avoiding tragedy.